get started with this one. It is 8 questions, so please bear with me. So, what's the first thing that I do? Yeah, read the question. So, I am starting with question 16. Dynamo theory can be applied to other planets that have molten cores. Hotter planets are more likely to have molten cores. So that hot planets have dynamo theory. Which of the following planets would the theory most likely not apply to? So I'm looking for what, a hot planet or a cold planet? Cold, right? Because it says it doesn't apply to them. So let's find my cold planets. Okay, before we even go on, who remembers like the My Very Eager Mother just gave us 9 pickles thing? It's not gave, but you know the order of the planets? Okay, closer to sun is going to be hotter or colder? Hotter. Right, so which of these planets is Neptune? Close or far? Far. Far. Is Mars close or far? Close. Close. It's the third. Venus? Close. Yep. Mercury? Close. It's the first. So, you guys really didn't learn that in school? The My Very Eager Mother just served us 9 pickles? I didn't learn that. But did you learn an acronym for it? No. Sad. Sad. Growing up in the 2000s breaks my heart. Alright. So, if I know the order of the planets, I can know that, but let's see if I can find it from in here. Because I know the My Very Eager Mother. So I know those ones just because I was a child in the 90s and that's what we were taught. Apparently we were not taught that in the 2000s, which is sad. Great, some of us were taught in the 2000s. Yeah, you might actually just have to know that for this question because I don't see it in here. Do you? Yeah, okay, so why is there so much talking? Like strike 2 as far as I am concerned. Okay, so this is not given in the passage. There are very, very, very few things that you need to know on the science ACT that are actual science, but apparently the order of the planets is now one of them. So the answer is Neptune for that because it's far away. So this is the only one that uses background knowledge that we've seen probably even all year. So we've been doing this for 4 quarters and this is the first one that has so much background, or that has any background knowledge that we need to know. Okay, question 2. Which of the following pairs of statements best accounts for Earth's geomagnetic reversal according to the 2 scientists? So I need to look at what scientist 1 believes and what scientist 2 believes. Well, their main point comes, and I'm looking for the Earth's geomagnetic reversal. Their main point should be in the first 3 sentences, but I want to find the geomagnetic reversal. So, dynamo theory helps moving fluid can help maintain a magnetic field. Earth's core is made of molten nickel and iron. The constant motion of the core causes currents, magnetic field. So scientist 1, if I'm making notes down here, which I am, scientist 1 says that the field is due to moving fluid. And it is the byproduct of the dynamo effect. So scientist 1 says the dynamo effect, that's the thing that causes geomagnetic reversal. Okay, scientist 2 agrees that the molten core is responsible for the field, but now let's find where it talks about geomagnetic reversal. So, when the regular motions of the core resume, the resulting magnetic field will either remain as it was or emerge as a reversal. So scientist 2 says that the motions of tectonic plates, so motions and seismic events, that's just earthquakes and tsunamis, seismic cause reversal. Okay, so one says it's the dynamo effect, and one says it's the seismic effect causing a disruption. Alright, so scientist 1 says that it is a consequence or an effect of the dynamo effect. So that's my choice for scientist 1. So I'm between C and D, just looking at scientist 1 because that was in there in the sentence. It says that it was an effect of the dynamo effect. Alright, scientist 2 says it's seismic stuff. So seismic disturbance and magnetic field resets. And so now I need to pick between these two because I found my key term of seismic. So I'm going to go back to the passage one more time. And it says, when the regular motion, so such events can disrupt the motion of the core when the regular motions resume. So it's saying when it goes back to normal. So that for me is a reset. So the answer is C. Right? So my reset, the key term there is going to be resume. Oh, beautiful. I'm going to add that. So Kyla found, return to previous state. Beautiful, perfect. That's even more proof of a reset. Okay. Why are you having trouble focusing today? Based on scientist 2's account, so my locator is scientist 2. Seismic activity that affects the Earth's molten core must be able to resonate to depths of at least. So, seismic activity that affects the core. So I need to talk about seismic events. So I'm going to go back to this scientist again. The motions of the core create a magnetic field. The motions of tectonic plates have a powerful effect on the core. So, let's see. I'm going to look at my diagram. Right, so to affect the core, my core is all the way down here at 2,900 kilometers. So if I look at my diagram, the core starts at 2,900 kilometers. So the diagram shows the core at 2,900 km. Questions on that one? Cool. Alright, number 19. Which of the following statements is most consistent with the ideas expressed by scientist 1? Scientist 1 is the one that talks about what? Yeah. Scientist 1 talks about dynamo theory. And then his main point or her main point was that the motion of the fluid causes the field, right? So if we go back to scientist 1, right here, it says dynamo theory. So constantly moving fluid can help maintain a magnetic field, and our core is made of molten nickel and iron. So the first sentence there, dynamo theory, says that fluid creates the magnetic field. So the motion of the molten nickel and iron creates a magnetic field? Maybe. Motion of nickel and iron counteracts magnetic field? No, that's like the opposite of A. But from a strategy standpoint, these two things say basically the same thing but in reverse. So I'm going to cross off C and D right away. Because if I have two things that are so similar to each other that they're opposites, it's probably between those two things. So between these two, the answer is A. And you find that in the first sentence. So your proof is in sentence 1. All right, 20. Which of the following hypotheses would both scientists agree on? Both scientists. Dynamo theory is which scientist? Scientist 1, so I can cross off F. Actually, maybe not. Although the scientist, I maybe can't cross it off yet, so I'm going to cancel that. So, eddy currents create seismic disturbances. Seismic disturbances cause magnetic reversal. That's scientist 2 for sure. We'll see if it's scientist 1. The dynamo theory is relevant only every few thousand years. I'm going to cross off J because that's just not, that's like a throw you off answer choice. Right? That doesn't even make sense. They never even mentioned the amount of years. So that's never mentioned. Okay. So we have F, G, and H as our maybes here. So now, let's go here. So, the constant movement creates eddy currents, which help create the magnetic field. Motions of the core, in accordance with the dynamo theory. Oh, so scientist 2 does talk about the dynamo theory. Create a magnetic field from eddy currents. Alright, so eddy currents is mentioned in both, but it says eddy currents creates what? That's the answer choice. What does it say in the passage? This says the motions of the core in accordance with the dynamo theory create a magnetic field from eddy currents. And this says the motion of this portion of the core creates eddy currents, which in turn help create the magnetic field. So what does it say eddy currents create in the passage? Yeah, not seismic disturbances. It says the magnetic field. So I can cross off H and G right there. It's F because both mention the dynamo theory. So I was going to cross that off, but I actually didn't read all the way. So, but you see how this says in accordance with the dynamo theory? And this says the dynamo theory suggests. Those two things mean basically the same thing here. So scientist 1 and scientist 2 agree that the dynamo theory exists. So I almost made a boo-boo. Made a boo-boo. But I didn't. Okay. 21. According to the passage. So the passage is my locator. Which of the following is a reliable indicator of the polarity of Earth's magnetic field at a particular point in time? Now, do you see how this says according to the passage? Usually, on a fighting scientist passage, if it says according to the passage, the answer is going to be actually in the blurb before you get to scientist 1 and scientist 2. Because that's the passage. So, sometimes you have to read on, but usually the answer is there. So, Earth's magnetic field has two distinct poles, north and south. Certain materials, such as iron and steel, are sensitive to Earth's magnetic field. The origin and behavior of the field is modeled by the dynamo theory, which links the magnetic field with the geological activity of the core. Diagram, blah, blah, blah. Evidence has been found of complete reversals of the polarity. Concentrated deposits of rock with reverse magnetics have been found in the ocean floor. Geomagnetic reversal sporadically over thousands of years. Blah, blah, blah. Okay, so I don't really know if I have the answer yet, so now I'm going to go back to the answer choices. So, what is a reliable indicator of the polarity of Earth's magnetic field? Molten nickel and iron wasn't mentioned in that passage. Deposits of magnetite rock was mentioned. Seismic activity was not mentioned. And shifts in solar magnetism. Did they talk about the sun at all? No. So you do need to know what solar is for that one. So those X's that you can't see because I wasn't on that question. Those X's mean it wasn't mentioned in that first part. What was the only thing that was mentioned? Yeah, because, so the answer to that one is B, because of this sentence right here. On this one, it says concentrated deposits of rock with reversed magnetic properties. That's my answer to 21. Alrighty. 2 more questions, and remember this will always go on YouTube so that you can watch it if you miss something before you turn in your annotations on Monday, because I won't be here tomorrow. Alright, if it were discovered that the polarity of Earth's magnetic field can be directly altered, oh now we're mentioning the sun, by the activity of the sun's magnetic field, how would this affect the viewpoint of each scientist? Okay. How would this affect the viewpoint of each scientist? Well, which scientist talks about the sun in their answer? Yeah, so neither talk about the sun, so it would what? Perfect. Neither talk about the sun. It would make both of them wrong. Any questions on that one?
No.
We didn't even have to read that. Beautiful. Alright, in a computer simulation, last one. In a computer simulation, the effect of seismic activity on the motion of the Earth's molten core was studied. Which of the following would be consistent with Scientist 2's viewpoint? The seismic activity would be caused by the motion of the core, cause significant disturbances. Shh, stop talking. Cause significant disturbances. I should have Chromebooks closed too. In the core, have no effect or cause eddy currents. So what does seismic activity do according to Scientist 2? So, I'm going to flip all the way back to Scientist 2. Now, this says, the motions of the core create a magnetic field. Tectonic plates and other seismic events have a powerful effect on the core. The events disrupt the motion of the core to an extent that the magnetic field turns off. So this scientist says that seismic events will turn the magnetic field off. So seismic will turn off the field. Okay, so be caused by the motion of the molten core. Nope, they said motion of tectonic plates. If you read that sentence, it says it was caused by the tectonic plate, so I can cross off A. Bless you. Cause significant disturbances in the core? Maybe. Have no effect? Definitely not, because it literally says the opposite is true. It says has a profound effect. Cause eddy currents in the molten core. No, it didn't mention that after the word seismic. So my answer to that is B. Questions?
No.
Crazy.